Hello everybody. Today we shall continue with the design of RCC T-beam bridges, and this is our lecture number 18. So, reinforced concrete road bridges, lecture number 18. We shall start with two things, RCC T-beam bridge and Coulbon's method of load distribution. Let me tell you that, let me show the thing here. We started with something that your problem statement that we would like to continue, and within this limited time it may be difficult to complete the whole problem. We shall give the basic principle and then we shall upload the PDF file of the whole solution, and so that you can go through it. But our objective with this time, we shall give the basic principle how to approach the problem, how to attack the problem, you can say, and that we would like to find out here. Coming to this one here, as we can see that we are having here that crash barrier, then we are having footpath, and then the middle portion we are having that first deck and your wearing coat, and then we have given a uniform one, though exactly that is not uniform, that one we will get the different dimensions, we shall get it. So, coming to this one, considering our requirement, as we noted that one, this is 450, this is 1500 and this is 7500 the carriageway, and then we are having this portion again another 1500 like that. So, it comes as 11400. As I have told you last class also that 225, 200, 215. So, that way they come that maximum you can go to 250, 275 also at selected places, not uniform, that we give it, and this is very much nowadays it is very much competitive that your thickness they give it, even sometimes they give it 210 also 215, that as much as possible they can save it. So, this is the one they do it, but as I have told repeatedly that whenever we consider that your reinforced concrete section, it is always better to have say section more, because that concrete can take that more moment of resistance, and still we shall save as much as possible. So, coming to this one here, this is the section that we have to provide. Our objective is that we have to provide this section, that your spacing and your overall depth d, and then your that b whatever we have got it. So, that means here we can say that we are giving that particular one say 2700, and this section we are giving it here, as we have noted down that one here, just to give you idea, and we have discussed also. So, this is our section and we are providing the haunch like this, it will come. So, another, since we are considering 3 girders, sorry not 3 girders, 4 girders. So, this is sorry, this one it will go little more, it is supposed to, but anyway. So, our objective is that we are giving this particular spacing 2700, and this one 11,400. Our objective is that we have to provide this section, and one objective obviously that we have to provide this section, that one say we consider here say overall depth D. Then we are having this section, and including inside also we can consider 225. Then we can give haunch here. There are many more things we can give, 250 or 200 horizontal, 150 vertical, like that we can give. This thickness generally it comes in the range of 300 to 325, 350 also. Let us say we are giving here 325. This dimension we are giving here 625, that one we are giving. That means here we can give that one say 150, 150 both sides we can give. That is the one. If you give 650, then we can provide 350. So, like that we can make it here. Now, what is our objective? Our objective is that we have to design of slab. So, whenever you are going to design slab, that means we have to find out this thickness. Let us consider that one as a ds, depth of slab. Now, when we have to find out design of slab, then what we are doing basically here, this particular one, then we are making it as a panel. So, this panel, this is the one traffic direction we are talking. We are talking this one as a traffic direction. So, when we have this traffic direction, and this is your one side that cross girder, this is your another cross girder or diaphragm, whatever it is. Diaphragm means at the end we call it, that is diaphragm. Intermediate cross girder we call it, that we can have. Since we are talking say 20 meter span. So, our objective here, let me write down this one here somewhere, a span 20 meter. Nowadays, there is a tendency that they use this one of certain kind of say your that less number of your say. I shall come back to this one. Before that, let me tell you, because so if we consider this one, and then we are having certain portion overhang. Let me consider that one here, overhang of different color. So, if you take look from this side, A and A, then let me show you the actual screeniness of drawing again. Then you will get this type of configuration. This is the configuration you will get it, that if you take a cross section of the bridge, that then you will get this. That means, the way I am going through the bridge along the traffic direction, then I shall get this cross section here. Now, what I am trying to say in this particular figure, what I am trying to say, that particular one, that how many cross girders we shall provide. As I have told you, nowadays that people actually giving less number of cross girders here, that in diaphragm only they are giving, but in earlier book all those things you will find out that they are having more number of cross girders. So, what we suggest, that at least it should be at least say less than equal to 10 meter, that is the one, at least this particular one, because from lateral stability point of view, if we give 5, that one here, that lateral stability point of view, at least you cross girder not more than 10 meter spacing, that way you can give. So, when we shall come that one, then it will become a different philosophy. What is that one? That if we provide the cross girder here, then what will happen, this length is more and this one, then in that case what will happen actually here, that we are that your this one will be almost like a say one way slab that will go on here. But if we provide one more, then we can get that. Now, this design of slab, as I have told you earlier, we use it by that Pigou's curve, that what I have told earlier, that particular one. So, just once more I shall repeat once more, this type of curve we get it here. On the basis of that we have discussed all those things like this, that we find out depending on u by v, that impression v by L, we do it here, that is the one we do it. Now, coming to this one here, that means we are solving this problem, first step, that design of slab, that is the one we are doing it here. So, and that one, for that, for earlier in solid slab we have used that effective width, effective length that we have calculated. Here we use by Pigou's curve, that is the first thing we do it. That means, depending on the impression, whatever we are having this impression of tire or track, whatever the load, whether class A load, whether 70R tracked or wheel or class A wheel, and then you will get the dispersion. On the basis of that you will find out, and then we know the length and breadth, and from there we can find out the value of M1 and M2, and from there we can find out the value of that moment, that we can find out whatever force we are getting, that we can get it here. The way we have done it in IS 456, that two-way slab that we have done it, that is for uniformly distributed load that is available in IS 456. Similar fashion, that it is concentrated load with the dispersion other thing, that we can use it, this is the one. So, this is your that step, and on the basis of that, generally most of the cases what we do, we check the section, that most of the cases the bridges are so standard nowadays, you can find out that 20 meter, as I have told you, RCC beam means 20 meter span, that is the one, it can go from 18 meter to 22 meter like that. So, we make the configuration, and on the basis of this configuration, we make the configuration, and on the basis of configuration we check whether these sections whatever you have provided, that is all right or not. This is the one we do it. It is rather we can say analysis of section rather than design of section, that is the one I could say. So, we used to say that one analysis of section you can say. Next one we have the loading given here, that you say cantilever beam or cantilever slab. So, next one is the cantilever part, that we have to find out. For that case, what we do, we can find out the load, let us see. The load we can find out, let us say, so this is the one cantilever section. Now, we have to find out the bending moment and shear force, and this one determinate. What we have here? We have this section of crash barrier. So, like this, and then we have footpath, So, whatever we are having the footpath, that we can find out here, that footpath. So, we have to consider this load, we have to consider. That means, we can say it is like this. Maybe you are having this load, this is the load of the deck. Then we can have, let us say whatever we are having this one, that projection, that is almost it is coming overall, that we can see, and you can actually take the section such a way that your vehicle will not come this side. That also you can, that you can take your overhang portion such a way that your footpath will come within that. So, that means not partially certain portion vehicle will come, certain portion that way. Instead of that, you can make your geometry such a way, so that it will be there, that full footpath load will come. So, if it happens like that, so first one we are having dead load of deck, second one dead load of footpath. I can consider this one as A and this one as B, dead load due to crash barrier. Now, this one we have something, the name that we should tell you actually here. One we call it actually DL, means dead load. Another one we call it SIDL, superimposed dead load. Then we call it, say, FPLL, footpath live load. We can sometimes we call it VL also. Let us consider that one LL, that is the primary one, we can say, which is your, say, vehicle load. So, these are all we can call it as a gravity load, because all coming down that towards down, that one you can say. Under this SIDL, whatever you are having, that means you are having that not here applicable for cantilever part, this one it is not applicable here, but wearing coat, actually it should come here number 2 and this should be number 3 anyway. So, wearing coat, that one also will be your, say, superimposed dead load. So, we can find out dead load means only you are talking deck and your beam, that web, that we can consider that one dead load, and whatever we are, because that is the one we are constructing, over that you are putting all of them, that footpath, crash barrier, all those things, and footpath live load that way. So, this one we consider, and we for each of them actually you can actually that find out that your bending, our objective is that to find out the bending moment shear force. Nowadays, whatever we do actually here nowadays in using different actually software, popular software actually available, that one, say, you are having now STAD, very popular one, STAD, then STAD Pro, or you are having, say, SAP, or you are having, say, CSI Bridge, and then you are having, say, Midas. There are different kinds of software actually available and you can use it, and that particular one whatever we can do, you can actually make it as a frame or beam element, frame or beam element you can say, that we can use it, and we can make this frame, we can make it and we can apply that. So, that means we can consider this one here, we can say from here, let us say this is 1, this is node number 2, node number 3, node number 4, say let us say node number 5, like that we can give. This way we can make it. If we want to make it further, then we can make it here also one node, here one node, here one node, at quarter point also we can make it, and in this fashion actually we can make that frame, that your grid, and that also you can analyze it. But our objective here, that we shall go to the problem that very classical way, the way they do it, that how to that distribute that which girder will take how much load, that we would like to find out. That is our objective here. So, this particular way also, if you, because your bending moment shear force if you can find out, and then obviously then you can go for standard design, whatever we are having, either you go for as per IS 456 or say IRC 112 or any other code, that particular one, that with the limiting values whatever they have, that you can find out, you can solve it. We shall give you this particular one, your in that you would say that a PDF file, that we shall give with the complete detail, because we feel the basic principle if you know, then it is very easy to solve it. So, cantilever beam, this is your another one, we design it, say slab here, that we have to design. Next part is coming, that is the one called girder. Or there are in our case, that is say your T beam in this case. So, question is that one here, it has own self weight, no doubt about it, it has own self weight, and then whatever loads are coming, that particular one you can consider. Now, under this we can say that your how shall we actually go ahead, because how shall we distribute the load. So, we are having the deck, we are in court, footpath, then crash barrier. This part, one way we can think of it, then you are having say T beam, that vehicle load. So, we are having different components, that footpath live load also I can keep it. One thing I always recommend, that you always try to find out what is the contribution of each of them, then it will give you an idea that which one is actually more governing, which one is giving more load, that particular one you can find out here. Out of that particular one here, what we can do, wiring code that is distributed, footpath, crash barrier, how shall we consider? One alternative could be that if you really consider that, just coming to the screen, we can say that if you come back to this particular one here, I can say one proposition could be that this load will be taken by this outer girder. Similarly, this load will be taken by the outer girder, that is one alternative. Other alternative, whatever load we have, I shall distribute everything over the all girders, that is also another one. So, that means whenever you are doing that assumption, you should have the knowledge that how much actually difference is there, that is the most important in our design, that how much actually difference, that particular one we should know. So, coming to this particular one here, Our main objective here, because directly we can find out this one, if you really say, that means the intermediate girder if you consider. So, obviously, I shall take the middle portion from here to middle portion I shall take, which will be taken by this girder, and whatever load we have, that particular we can have. But regarding vehicle loading, we shall have certain problem, because we have to follow that IRC loading that we have to follow. So, next question is coming, that as I have told you, I have taken here 1700. So, whether this 1700 is all right or not, that we have to check. That means, your overall depth, that particular one, whether it is all right or not, that we have to check. So, coming to this one here, what we can say, that our objective is that we have to design of girder. For that we are having different loads. Deck we can find out, as I have told you, that we can take certain portion from here to here. And then again other portion will go, that means we are having certain portion, say flange. We are having this one, say your BW. So, like that we are having this one, say DS, and then we are having this one, say overall depth. Now, coming to this one here, very interesting thing I would like to say, that generally it happens whenever we considering that beam, then certain portion that if you see this one here, you will actually get two lines, though it is not up to the scale, but you will get here two lines. What are the two lines? Those two lines, just let me draw the figure here. So, one line you are getting here, this portion, another one if you cut it, another one we are getting here, this portion we are getting here, that particular one we shall get it here, and similarly we shall get it here also, we shall get two lines, we shall get it here, we shall get here one line, here one line, we are getting that particular one here. Now, as I have told you, this is one your say support that we get it here, sorry, span. This is the one we are having, say span cross section, whereas this is support cross section. So, this width and this width same. Generally it happens, say for example, this one it comes something in the range of 625, this one say 325. Old bridges you will find out that one 350, 650 like that, and nowadays we generally find actually this particular one we are getting in this particular fashion we are getting. So, that means from support we are starting from here, then we are coming up to this level, and that one we shall find out how much we shall get it here, that we have to find out here, and so it will go up to certain level, and that generally we can give say here something in the range of say 1200. Sometimes people used to give 900 also. So, 1200 something like that way. Then in between you are having say another 1200, you will have that flared. That means, if you see from the top, and then it will go. This one we are looking that plan. Then this one 625 and this one 325. So, this portion you are having that from this one 625 to this particular one negotiated of 1200. So, if we now draw the figure, very interesting thing we will find out. This is the one say I am getting here, that particular one we are getting. Then what we shall do here, this is the UDL for this section. Then further I can have another load UDL 1200. Further I can have so we can find out for each of them, we can find out the bending moment of medial, like that we can find out, and we can see what is the difference you are getting it here. So, that we can find out here, that is the thing we can solve that particular one here. Then the next part I shall tell you that you regarding that you would say that girder load due to the live load, how much it will come, and then we shall discuss the remaining part we shall discuss. So, this is the thing that I would like to say that particular, and I shall just give you that one the complete solution for each and every one we shall give, so that you can go through it and which will be helpful for your say your assignment also. So, that we can find out. So, step by step we can give that particular one here, because the process is lengthy and within this particular time we shall not be able to, but the basic principle is that how to actually move forward with this problem, that what I am trying to say first. Thank you very much.